Graphing rational functions. A rational function is basically a function that has a fraction in it, in which you have at least a variable in the denominator. You may or may not have to have one in the numerator, but it has to have one in the denominator. Here are two examples of rational functions. This one over here, when you type this into your calculator to graph it, you want to put the 1 on top, then divide, make sure you put the whole denominator in the parentheses. Then when you graph it, it should give you a graph similar to this one here. The problem over here on the left, when you graph that on your graphing calculator and type it in, you'd need to have the whole top in parentheses, then hit divide, put the whole bottom in parentheses. Then you would want to go ahead and graph it. Now, these two functions give you the two different things that occur with rational functions. Here, at x being negative 2, we have what's referred to as a vertical asymptote. It's an imaginary line. It's not technically part of your graph, but it's a line that your graph gets close to, your function gets close to as it goes on one side here, gets closer and closer to that as it goes up forever. On the other side, it gets closer and closer to it as you go down forever. The other situation that occurs with rational functions when you graph them is sometimes you can just have a hole, a break in your graph right in the middle of everything. Now, this one here has a problem at x being negative 2. This one here has a problem at x being negative 2. We have a problem at x being negative 2 because when x is negative 2, it causes the bottom here or over here to be 0, and we know we can never divide by 0. So, when the bottom ends up being 0, you may have a vertical asymptote or you will have a hole, one or the other. It won't be both at the same spot. Now, when you look at this first function, the top is really differences of squares. So then it factors into this over this here. You'll notice that this function is still undefined at x being negative 2 because that would cause the bottom to be 0. But we do have a common factor in the top and the bottom. That's your x plus 2's. So when your x plus 2's drop out, you're only left with that x minus 2 in the top and nothing on the bottom. But it would still technically be undefined at x being negative 2 because your original function was undefined there. Whenever you end up having a common factor in the top and the bottom that drops out, that's when you have a hole. The problem over here on the right, we did not have a common factor in the top and bottom that dropped out. So whenever the bottom was 0, that's your vertical asymptote. So if you have no common factors and the bottom is 0, you're going to get vertical asymptotes. But if you do have a common factor in the top and the bottom, that common factor drops out. What causes that common factor to be 0 tells you the coordinates of your hole. So what causes your x plus 2 to be 0? That's where your x is negative 2, and that is where your hole is. By the way, as a side note, when you look at what you have left after you take out your common factor, you realize it's an equation of a line, slope of 1, y-intercept of 2. So you can graph it, but just remember when your x is negative 2 on your graph, you got to have a hole there, so just a little open circle. So just to review, when you have a common factor top and bottom, we end up having a hole, and that would be a hole or a point of discontinuity. When you don't have a common factor in the top and the bottom, what causes the bottom to be 0 is a vertical asymptote. Sometimes rational functions also have what's referred to as horizontal asymptotes. A horizontal line that your graph would get close to as you go far to the right and as you go far to the left. Your graph may never cross your vertical asymptote. However, your graph may cross a horizontal one. So let's go ahead and take a look at these. We need to go ahead and find vertical asymptotes in any holes. Well, to find vertical asymptotes in holes, you first of all have to go ahead and factor. The top is differences of squares. The bottom factors into two different parentheses. Now, since you have a common factor in the top and the bottom, You know what causes that common factor to be 0 is a whole. So that is when x is -2. So when you cross those out, you know you have a whole at what causes those to be 0, which is a -2. You look at what's left. Since we have this left then, there's still a denominator. What causes that bottom to be 0 is -3. So we'd have a vertical asymptote at -3. So this particular function would have a whole at -2, because that's what causes that common factor to drop out, and a vertical asymptote at x being -3, because that's what causes your bottom to be 0. Over here, we factor top and the bottom. You look at your common factor, the x plus 3's, and you think what causes that to be 0? That's -3. So you cross those out, you're left with this right here, and that's what we have right here. Still with our whole at -3. We still have a denominator left, so we know we'll also have a vertical asymptote at what causes that to be 0, and that's when x is a -5. Keep in mind that your asymptotes are lines, so you always need to write them as x equals for it to be a vertical line. If you had only put -5 and not x equals -5 over here on this one, you would not get it correct on your test. So here we need to go ahead and graph this rational function. The first thing you want to do is to go ahead and find your holes. After you found your holes, you want to look for vertical asymptotes. Then go ahead and find your x and y-intercepts. Your y-intercept is when x is 0. Your x-intercept is when y is 0. Then if needed, go ahead and make yourself a t-chart. So following those steps here on this problem, you want to go ahead and factor it on the top and the bottom to find any holes. Well, the top and the bottom here doesn't factor. Since we have nothing the same top and bottom, we have no holes. However, we still have a denominator, a variable on the bottom. So what causes that variable on the bottom to be 0, which is when x is -1, is our vertical asymptote. So now, to find your y-intercept, you need to go ahead and plug in 0 for x. So you get 0 on the top over 0 plus 1 on the bottom. Your x-intercept is when you plug in 0 for y. And we end up getting 0 here. When you plug in 0 for y, up here you get 0 equaling your fraction, which we have right here. Then you could go ahead and you could cross multiply. You take this times this, you get 0. This denominator times this numerator, and you get x. You get x be 0, so that's why we have our 0 here. Now I would go ahead and I would choose values on each side of my vertical asymptote, which is -1. So I'm going to take -1, choose values on each side of it, and plug those into my function up here. When I do that, I will get these values here out of my function. Then I need to plot these points. 4 to the left, a little more than 1 up. 3 to the left, 1.5 up. 2 to the left, 2 up. At -1, I would draw a vertical asymptote, a vertical line, but draw it dotted at x being -1. I'd also have the point 0, 0, the point 1 over, half up, 2 over, 2/3 up, 3 over, 3/4 up. When you draw that in, you would get this here. When you plot your points, you would just have something like this. But you'd also have your vertical asymptote in here. Typically on one side of your vertical asymptote, you're going to go up. On the other side, you're going to go down. As you look here coming down across here, you know it's going to be going down because that's kind of how the points follow. Over here, you know you're going to go up because you know as you follow the points, they start to go up. In this case, there also happens to be a horizontal asymptote at x equals 1. And you could get that by just plotting more points and seeing that it starts to level off at a height of 1. We want to do the same thing here. So you need to factor the top and the bottom. You'll notice you have a common factor in the top and the bottom. What causes that common factor to drop out and give you 0 on the top and 0 on the bottom? Or what causes that to be 0? x plus 4 equaling 0. You solve that, you get a whole at x equaling negative 4. Well, when you look at what you have left, after you cross out your common factor, these are gone. You're only left with that parentheses, so it's really just x plus 1. Well, that should be fairly easy to graph. You know that that's an equation of a line with a slope of 1, because that's what's in front of your x, and a y-intercept of 1. So you could just draw yourself a line, slope of 1, y-intercept of 1. But if you wanted, you could make yourself a t-chart. Now, making yourself a t-chart, I would go ahead and plug stuff into here. But keep in mind, when x is negative 4 right here, it's a hole. Yes, when you take negative 4 and plug it in here, you do get a y value of negative 3. That just tells you where to put that open circle on your line. If you wanted, you could also find your y-intercept and your x-intercepts. Now, there are times you can have more than one vertical asymptote. In this one here, if you would factor in the bottom, you would get an x minus 3 and an x plus 2. You would have two things in the bottom that would be 0, so you'd have two vertical asymptotes here. Sometimes, like in this case, it goes down in between your two vertical asymptotes. Taking a look at this one over here, it's still going to have the same vertical asymptotes, but it's going to look different. In this case, in between your asymptotes, on one side it goes up, on the other side it goes down. But notice in most of these, if you take any one vertical asymptote, on one side it goes up, on the other side it goes down. Is it always that way? No. Is it common to have that? Yes.